All right, so today we are looking at 3H and 3I. Now 3H and 3I, we're not going to be doing a lot of calculations. It's more about understanding. And yeah, so it's more just about understanding and making sure you know what we're talking about. So depending on how quickly we get through this, we might go through start chapter 4 as well, because there isn't a lot extra here.
What's our SAC?
Not till next term. It's about 8 years.
So
Yeah, no. Yeah. So you only have 4 years, yeah, for maths.
oh my god, that's really
Alright, so let's concentrate on up here. So today we're talking about correlation and causation. And pretty much all this is saying is that just because we've got two variables that show a correlation or show an association does not mean that they are related. So, or they may be related, but there might be other things that also affect that relationship. So the example we've got here is there is a strong association between the number of Nobel Prize winners and the number of IKEA stores in that country. So I can say, okay, well, that's a random relationship. But does this mean to increase the number of Nobel Prize winners in a country, that the country should build more IKEA stores? So we can see if there's a relationship, and they said that there's a strong one, so 0.82. So we know that if we had a scatter plot, it would look something like that, which is a fairly good relationship. But there could be other factors that influence that relationship. What could these other factors be? They can be as random as, well, not random, but as left of centre as we like. We just need to think of a few things.
Could it be like the amount of people that live in the country?
Yeah, absolutely. So we could have population, could definitely be another factor. What else could we have? We could have like the GDP of a country, so how wealthy that country is. You'd think wealthier countries would maybe have more IKEA stores. It could be the location of the country. So we think countries that maybe more European countries have IKEA than Asian countries. So we've just got a few random things off the top of our head that could also affect our association. Does that make sense? Yeah? Cool. All right, so to establish causality, we first need to have an experiment which needs to be conducted between the explanatory variable and the response variables. And we need to make sure it's a really controlled experiment so we can eliminate as many other variables that could affect it as possible. So an example of this would be if we had a class. All right, so let's say we have this class and we split it into two groups. One of you's got to go into a class on time series, which is some maths. The rest of you are going to go into a class on Shakespeare. Then you're both going to do a test on time series, which is what the first group learned. Which group do we think would do better on the test? The time series group, obviously, because they've learnt about it, and the people that went and learnt Shakespeare have learnt something that's absolutely got nothing to do with time series. So in that, if the time series group got a better mark, which we would expect, then we can say, yes, learning the more time spent studying on time series, the better your mark can be. Because we've eliminated all these other factors. We've eliminated things like, how many lessons you had, or how much experience you've had with time series, or anything like that, or how good you are at maths. All we've done is either you've done the class or you haven't done the class. And so we've made it really controlled. Does that make sense? So that is how we can closer to 100% say, yes, this affects that completely. So if we're looking at this example, which I just talked about, so class is split into two groups. One will take time series, one will take Shakespeare. Both will be tested on time series. What is our explanatory variable in this? Out of these two, time series and lesson on Shakespeare. What would be our explanatory variable? Which one? Lesson on time series or a lesson on Shakespeare? would be our lesson on time series. Because that's the one we're trying to test for. And our response variable will be our test mark. Does that make sense? Yeah.
So we didn't really mention the Shakespeare lesson.
No. Because it's either, we could have lesson on time series or lesson on Shakespeare, but it's just as long as you've got one of them written down, and the lesson on time series would have more of an explanatory effect than the lesson on Shakespeare, so that's why we choose that one instead of Shakespeare. But no, you don't have to mention it because the lesson on Shakespeare isn't a response variable. It's how well they did in the test.
So if you wrote down Shakespeare and added the time series lesson,
That would be fine. Yep,
Oh.
that would be fine. Okay, so after the test, it is shown that a group had the time series lesson did better on the time series test than those that did the Shakespeare lesson. As this is a controlled experiment, we can conclude that the type of lesson studied had affected Am I okay to go down? Anyone still copying? Okay, so when we are talking about other factors that affect a correlation, they usually fall into three categories. So there's either a common response or a common variable that can affect both the explanatory and the response variable, and that's what we call a common response. So what we've got, an example of this would be there is a strong positive association between the number of people using sunscreen and the number of people fainting. Does sunscreen cause people to faint? Would we say sunscreen causes people to faint?
No.
No, but what is common, or what is a common factor that would associate with fainting and sunscreen?
Being out in the sun.
Yeah, being out in the sun. Yeah, absolutely. So we could say no, but something like, but on hotter days, more people are likely to faint. And more people are likely to be outside wearing sunscreen. It doesn't have to be in these exact words, but just as long as you've got something that relates to each other and you've explained it. So things you need to have in your answer. You need to start with a definite answer. So if it's asking you a question, you need to give a yes or a no. Straight away, that's your answer. Then you need to explain. So you need to give a reason. So that's the first bit. So more hotter days, more people are likely to faint. More people are likely to be outside wearing sunscreen. So that's the first reason. So that's the reason. And then relate it in terms of variables. So relate it back to the question.
What was the second?
This one, so reason. So if you said no, well, why? And the third one, you relate it back to the question. All right, so then any questions about common response? No? Cool. All right, so confounding variable. So this is when the response variable may be affected by a third variable. So in our example, we've got statistics show that crime rates and unemployment rates in a city are strongly correlated. So we're saying that as unemployment goes up, crime rate goes up. The more unemployment there is in the city, the more crime there is in the city. Can we conclude that decreasing employment rates will decrease crime rate? Can we conclude that? So by saying we conclude it, we're saying that there is no other possible explanation or no other possible reason or way we can get crime rates down other than unemployment rates. What do we reckon? Now, what's something else that could affect this? If you think of, all right, even if we think of Melbourne, where are the areas that are associated with more crime? What's different about those areas compared to areas that don't have as much crime? Yeah, absolutely. So we've got the socio-economic status, absolutely. What else could there be? It could be something like education level. And these two probably relate a little bit as well. So the type of area you're living, whether you live in a really affluent area or a lower socioeconomic area, that can affect the crime rate. It might be the ethnicity of the area. So, you know, the cultures that live there as well. So, when we're looking at something like this, so statistics show that crime rates and unemployment rates in a city are strongly correlated. Can we conclude that, oh, I've got to double that there, that decreasing unemployment rates will decrease crime rate? Yes or no?
No.
No. Cool. So that's what we're going to start with in our answer. No. And we can say other factors such as So we're not saying that there isn't a relationship there, because unemployment probably does lead to more crime, but we're saying it's not the only thing that leads to more crime. So in your answer, again, you've got your definite response, your yes or your no. You've got your reason, so other factors, such as socio-economic status, education levels, or ethnicity of a city can also affect crime rates. And then relate it back to the question. So, the question's asking, can decreasing unemployment decrease crime? And we're saying, therefore, decreasing unemployment rates may not lead to a decrease in crime rates. We're not saying it won't, but we're saying it may not. Because there is a relationship, we can see that, we can understand that. We need to say it's not the only thing that will lead to it. Any questions about that one? No? All right, can I go down? Yep, okay, so the last one. So the last one of these we have is coincidence. And coincidence is literally, so they've got no relation, nothing to do with each other, and it's just pretty random that they affect each other. So when two variables show a correlation, but there may be no reason for them to be associated. So the example we have is, it is found that there is a strong association between margarine consumption and divorce rates. Can we conclude that eating margarine causes people to divorce? What do we reckon? No, probably not. So no, we need to put our reason in. So our reason could be, for a coincidence, you can literally say it is a coincidence. So it's important when you're doing a correlation between two variables that you think about what other things could affect them, whether there should be a relationship between two variables, and, well, I suppose how that affects the relationship as well. So it's more about understanding that you've just got to realise that other things can affect the relationship. Yeah?
When it's always going to have other factors affecting the relationship, will it always be no at the start of the answer?
Yeah, usually. Unless it's talking about they're in a really controlled experiment. Then you could say, yes,
So
we can conclude.
it's just for like Murray H that it's always going to be.
Yeah. It'll be really rare that you get a question actually asking you to write something like this. You might get one for the whole year in a SAC or an exam, but you just need to be aware that there are other factors that affect relationships and how they impact on our results. All right, any questions about that? Okay, and 3I is really just about looking at the different variables we have and then what type of graph we need to construct, which we've gone over. So this is pretty much just a summary of the different graphs we've learned for this chapter. So which will be handy to have in your books. Any questions about anything? No? Cool. All right.